Okay, today we're looking at section 20.3, real life graphs. So we're talking about liquid being poured into containers. Alright, so when water is poured into any type of vessel at a steady rate, the water will rise in the vessel at a steady rate. But it depends on the shape of the vessel. Okay, so here we have a cylinder. So as water is poured in at a steady rate, the height is going to rise at a steady rate. Okay, so when you have something uniform, i.e. like with our prisms, your graph is going to be a straight line. This is time, so as time goes on, the depth of water goes up. Alright, or it's a straight line because this is straight sides, so it fills uniformly. This will not be a straight line. So if you have to think about this as you're pouring water in. The bottom's going to fill up quite fast because it's narrow. Then it's going to take longer to fill up this middle bit because it's wider, and then this bit will fill up quite fast. Alright, so when you've got a curved shape, you end up with a curved line. Okay, so we're talking about the height, alright, how the height changes over time. So in this example here, match these containers to their graphs when they are filled with liquid at a constant rate. Okay. So with something like this, you need to identify what's the same and what's different. So these two things are cylinders. Okay? Think about water being poured into them at the same rate. So which one is going to fill up faster? This one, because it's narrower. So the height in this will get higher faster than this one. They are both going to be straight line graphs like we had above. So A and B are going to be 2 and 5. Alright? This one's going to fill up faster, so the height is going to get higher quicker, so that's this one, and then B is 2. Okay, then if we look at these three shapes, this one has a big cylinder and a small cylinder on top of it, and this one has a small cylinder and a big cylinder on top of it, and this has a cylinder, a cone, and then another cylinder on top. So these two have 2 parts, this one has 3 parts. So if you look at your graphs, the one that has 2 parts is this one and this one. Okay, again, when you're pouring water into this and this, which one's going to fill up faster at the start? So it should be D. D would fill up faster at the start because it's narrower and slower at the end, and this one will fill up slower at the start and faster at the end. So if you compare 1 and 3, so D is going to fill up fast at the start and slower at the end. C is going to fill up slow at the start and faster at the end. Okay, so 1 is C and 3 is D. So then that leaves E to be 4. And it's a cylinder, it's a straight line. This gives a bit of a curve in the middle, and that gives a little bit of a straight line at the end. But you would have found it by default by doing the other ones first. Okay, so you need to try and think about how quickly the height is changing within the container at the same rate. Alright, so all the questions really are comparing different vessels and seeing which graph goes with it. So give them a go. Alright, so exercise 20.3, page 473, questions 1 to 11.